When we think about this one, we're gonna think about this one in terms of this functional group. Again, there's always going to be some clues in synthesis to help us sort out what to do. And with this one, it's pretty straightforward because we only know one way in order to get a carboxylic acid at this point in the game. Now, later in organic chemistry 2, we're going to talk a lot about carboxylic acids, but until then, we only know that we can do O3 and water on an alkyne, do some ozonolysis, and that will get us a cleavage of this carbon-carbon bond right there. So I end up with one carbon and a carboxylic acid there. And so that must have been the reaction there. Now, that's where I lost my one carbon. So that carbon is lost. And now I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this guy only has 7. And so we've sorted out the carbon-carbon bond breaking that we had to deal with in this synthesis. Okay, so again, it's an alkyne. And so we know that we've already dealt with all of the issues that involve different numbers of carbons. So I can't do alkylation to make an alkyne. So the only other way that I know to make an alkyne is to do some sort of elimination. Now, there's a lot of different possible, there's a lot of different possible scenarios for elimination. I could have eliminated 2 bromines here, but it's much more difficult to put 2 bromines on the same spot than it is to put bromines across from each other. And so I could do this with some sodium amide, but since it's a terminal alkyne and I need to do another reaction with it, I'll have to reprotonate it, because if I don't, it'll stay an alkanite ion. All right, so how do I do that? Well, I think that if I were to have a reaction that involved a double bond here, I could do this with Br2. I could sort out adding 2 bromines between a double bond if I had a double bond there. Now, the only other question is, well, how do I make this into a double bond? Now, if I just do H2SO4 concentrated to eliminate the OH group, then it'll make the more substituted alkene, and that's not what I want. I do want the Hofmann product. So how do I do that? I have to make the OH into a different leaving group by using tosylate chloride, turn it into OTS, and then I can eliminate with T-butoxide. Okay, so what are all the steps here? So 1 is TSCl, 2 would be tertiary butoxide, 3 would be Br2, 4 would be sodium amide, 5 would be water, 6 would be O3, and 7 would be H2O. It looks complicated, but it's really 1, 2, 3, 4, 5 different reactions, because the ones that I made crosses with, they're just they're essentially the same reaction. Okay, great. Well, that's it for that one.